Hey guys, welcome back to another lesson. Today we're going to talk about solving polynomial equations. Specifically, we're going to solve by factoring, okay? And we're going to jump into sum and difference of cubes, how we're going to factor those guys. Today we're just going to talk about how we can use this to factor it, okay? I will be putting another video out there as to where this comes from, because I don't want you to think that this is just something that was just pulled out of thin air, okay? There is a reason why that when you factor it looks like this, okay? And we'll get to that. But today we're just going to worry about using it, okay, and how we can use it to factor. And that's it, okay? We're going to break this into two parts. The first part is cubics. The second part is factoring just a big, long polynomial expression, an equation, and we can factor by grouping, okay? So I don't want to make the video too long, so like I said, we'll do some cubics first, and then we'll jump into that part in the second part of the video, okay? So let's go ahead and get started. So if I have a cubic, okay, notice how A and B are both cubes, and I'm adding them together. I could factor it where I take the A and B value already, add them together, and then multiply it by this polynomial expression here. So I'm going to take the A value, square it. I'm going to subtract the A and B values multiplied together, and then I'm going to add B squared. Okay, now this might look weird. You're probably thinking, I don't understand that. Let's do an example, and it will click a little better. Down here, almost similar, but now it's a subtraction. It's a difference of cubes, okay? And we have almost the exact same thing as the top, except the signs are a little bit different, okay? Now, before I jump into that, let me just do a real quick comparison to what we did previously. We did the we did the differences of squares, not sum. And this was, what, A plus B and then A minus B, right? When we factored it, okay, that's what we came up with. So for instance, let me give you an example. X squared minus 9. If I was going to factor it, it would be X minus 3, okay, X plus 3. Okay, that's what this is. So I'm using a very basic knowledge of this, and I'm relating it to now cubics, which is this guy up here, okay? Now, like I said, I'll do another video where I'll show you where this comes from, but for right now, let's just use it. One final note before we jump into an example. A prime polynomial is a polynomial that cannot be factored. So in other words, if I get to one of these and I can't factor it, we call it prime. Doesn't mean there isn't an answer or anything to that. It just means I can't factor it, unfortunately, okay? So let's go ahead and we're going to jump into an example. All right, so let's look at, I'll tell you what, I'm going to put the example underneath here. Okay. Oh, I'm sorry, one more thing. Just popped in my mind. Because these are identical, and the only thing changing is the sign, here's an easy way to remember what the signs are. Okay, it's called SOAP. All right. Okay, you can use this little device to actually figure out what the signs are. S stands for same. So look at this. You see how the signs didn't change? They remained the same, positive to positive. O stands for opposite. Okay, so that's this guy. That's the O. So I'll put this. So this is S. This is O. AP goes together. Okay, that stands for always positive. Okay, and that's this guy right here. AP is this part. Okay. So there's SOAP. And the bottom one follows the same pattern. The same, the opposite, and then always positive. Okay? So it's a cool way to actually figure out, what the signs are when you are factoring this guy. Okay, now let's get back into the actual swing of things. Can I, we'll do it like this. I think we'll be okay here. All right, so here's an example we're going to try out. Okay. Now notice, okay, oh man, I'm going to turn the camera here a little bit so you can see it a little better. Okay, I want to keep this in view. Now notice this doesn't look anything like a cubic yet, okay? That's because your very first step is to factor GCF, if possible, okay? So a GCF for both of these guys would be a 2. I could factor 2 out of both of these, okay? And then I could factor 1x out, because they both have an x to offer. Now let's see what's left. So if I take a 2x out of this guy, I have an 8x cubed. If I take a 2x out of this guy, I get a 27y cubed. Okay, the x, I took care of it, right? I factored it out. Now, so this guy's my GCF. And to be honest with you, it's just going to come along for the ride. I'm not going to use it anymore. So you could ignore it for right now. This part right here, this is a sum of cubes. It's this guy right there. Okay, now what do I mean by that? How do I know it? Well, let's think of this. What do I multiply by itself 3 times to get 8? 2, right? 2 times 2 times 2. So that's a 2. And then what do I multiply x by to get x cubed? It'd be x again, right? X times x times x. I think I might have said that wrong. Sorry. Now, using SOAP, okay, the sign's going to be the same, right? What number do I multiply by itself 3 times to get 27? It's going to be a 3, and then y we would multiply by itself 3 times to get y cubed. Okay, so this part is your a plus b value. Okay, that's this guy over here. Okay, now we have the longer factoring part that we have to take care of. So the first part, notice, is a squared. So 2x squared would be a 4x squared. This would be ab, right? The next part's ab. So I'm going to multiply these two together. I'll get 6xy. And the last part's b squared. So 3y squared would give me 9y squared. Now notice, I didn't put the signs in yet. Okay, so let's use SOAP to do that. So it's same, opposite, always positive. Okay? And there we go. There is this guy being factored. If I multiply all 3 of these guys together, I do get the original. And I highly encourage you to multiply it out so you can kind of see that as well. Don't just take my word for it. Okay? So what do you think? Any questions on that? So that's one problem down. Let's do another example. Okay? And it's okay if you're a little bit slow at the start. Okay? This is something different. We haven't factored cubics before. So let's try this guy. Okay? All right, first step, factor GCF out. I can't do it. There's not a GCF, right? I can't factor a number out. I can't factor a variable out. Oh, I'm sorry. This should be to the third. Sorry about that. Okay, so now let's figure out the first factor, right? Let's figure out what a and b are. So what could I cube to get 8? 2. I'll put a y next to it. Plus, what do I cube to get 5? Uh-oh. I don't think there is one, huh? There's no value that I could cube that gives me a 5. Doesn't work. There's no value I could cube that gives me a 5. Okay? Now, a lot of you are probably saying, well, what about the cubic root of 5? Well, we're talking about whole numbers here, okay, for us to factor this. Not going to work. So this guy is a prime polynomial. Okay, just can't be factored. Now we can do other stuff with it. Doesn't mean that we just discard it like, bad equation, pew, it's gone. No, that's not the case. It's just we can't factor it. Okay. Wait, so far so good? Yeah. All right, let's keep going with this. Let's try another example. And I hate getting rid of that guy. So I'm going to put another whiteboard here. Okay, so let's do another example. Okay, so here's my next polynomial that I want to factor. And this doesn't look anything like that yet, right? So that's telling me there's a GCF I could factor. Okay, and my GCF that I could factor for this guy is a 5. And then notice each one of these has a y to offer up. So I could factor a y out. So now I'm left with y cubed minus 320 divided by 5. Okay, that's going to be 64. And then z cubed. Okay, so remember, if you can, factor GCF out. We're going to ignore this. We're not going to need it right now except for the final answer. Now we have this guy, right? Here is my difference of cubes. So that's the bottom equation I'm going to work out. Okay? All right. So my first factor part is what do I cube to get y cubed? It's y. What do I cube to get 64? 4. And then don't forget the z, right? Okay, because if I cube z, I get z cubed. And the sign is going to be the same, because remember, we're using SOAP to kind of remember what the signs are with. So there's S. Okay, now, and I'll just label it. So here's A, here's B. This is A squared. This will be AB, and then this guy would be B squared. Okay? And what I'll do is I'll put the signs in at the very end. Okay? So A squared is this guy. That'll be y squared. AB is I'm multiplying both of these. It'll be a 4yz. And then B squared is 4z raised to the power of 2, which would be 16z squared. Now the signs. Okay, so let's look at SOAP for a second. So this is going to be the same. This is the opposite. And this is always positive. Okay? And there is my factor. Now, a lot of you might say, wait a minute, isn't that a negative 4z? Shouldn't that be a different sign? And the answer is no. Okay? And to be honest with you, if you think about it, if that was negative to begin with, and the product of these two is negative, it still becomes positive. So, I mean, we're taking care of this. Okay, this does work. All right? And if I multiply all these together, I do get the original value. Okay? What do you think? So far, so good? Okay. All right, so that's factoring cubics. So we did one example that was a sum of cubics. Okay? We did one that was prime that didn't work. And then we did one that's a difference of cubes. Okay? It's a little weird at first. It's okay to be slow at this. Okay? Write this down. Okay? And follow it. And that'll help you a little bit. Okay? And remember SOAP. That'll help you with the signs here. Okay? And what the signs are going to look like. I do have other examples in my notes. Feel free to look at it. Tomorrow, we'll see. I'll upload part 2. All right, and we'll go from there. So I hope you're all doing well. Until next time, guys, I will see you in the next lesson video. Take care.